Let's look at the image layer in ProRaster. I'm using ProRaster Premium. So I'm going to add a new algorithm with an image layer. In an image layer there are three components. Firstly, the image, which acquires color data from a color data band in a raster. Then the intensity component, which provides hill shading. Then the opacity component, which allows you to modulate the opacity or the transparency of the image on a per pixel basis. Now you can turn any or all of these on in any combination, except that you can't have opacity turned on its own. But you can, for example, simply have intensity turned on and just provide hill shading, or you can just have the image turned on, or you can have them all turned on or both turned on. Most important component is the image component. So what the image layer does is it faithfully reproduces the colors from some imagery raster that you have. So an imagery raster will have a color data band in it. It will usually be red, green, blue, or red, green, blue, alpha. And that data will be reproduced without modification in the algorithm, except that it will then be changed by your intensity and your opacity components if you use them. So let's go to the raster source editor. I've got some ECW imagery here. So you can see that there are three images in this raster source: an ECW for the top, for the south, and for the central areas. And I want to display all those three images at once. So with a raster source where all the rasters have the same structure and are the same kind of thing, you can put the three rasters into one, and then you can just select that raster source, and they're all displayed at the same time by the one layer. So we have one layer with three rasters being displayed. So in the component property page for the image, you need to select your raster source. You can browse to one if you wish. Select the field. There'll almost always be only one field available. Select the band. In this case I've chosen a band that is called red, but it's not actually red. It's just misnamed in the raster. It's actually RGB. And you can select a time range, a data conditioning filter, and then your raster will display. On the color page, there are no options for modulating the color at all, or for changing the color. There's just these interpolation options. Let's zoom in a bit. Let's look at interpolation first. So by default, the image is being interpolated. It'll be using cubic spline interpolation. So we can override that here. Let's change that to nearest neighbor, for example. And now you can see that I've got a pixelated image. When you turn on nearest neighbor, you should also turn on the nearest option that's below all of these interpolation options. Because there are two phases of interpolation. The first phase, which is represented by this drop list, is the method that's used to produce the underview tiles. But then the underview tiles have to get rendered onto the screen, and that might involve some pixel shift, like a subcell pixel shift. And so there's an interpolation phase there as well. And that can either be nearest neighbor or it can be bilinear. And in most cases you're going to use bilinear, but when you use nearest neighbor for underviews, it's probably best to then use nearest neighbor for the second phase as well. So there's nearest neighbor. Here's linear, so this is a bilinear interpolation, and then there's a couple of cubic spline interpolations. So let's go back to cubic spline. So you can see from this ECW, it's got this white boundary around it. It'd be nice to remove that. So one way you can approach that is to use a data conditioning filter. Let's go into the data conditioning editor, and perhaps I'll remove this one and we'll make a new one. So I want to erase white. So I come down here into my color control, and white is going to be 255, 255, 255, and I'll add that as a rejected color. Now select that in my data conditioning list, and you can see that we've had an immediate change. Perhaps if we go back to nearest neighbor interpolation, you can see that some of the pixels have been removed, but others haven't. And this is pretty typical of older ECWs, where the compression noise is spread throughout the entire image, even out into the boundaries of the image. So what we can do with data conditioning is we'll modify this one. So we'll reject white, but we'll put a little bit of slack into our definition of white, so plus or minus 8. Hit OK. Now we've removed most of that white noise that's around the image. So that's one mechanism that you can use to remove those sorts of things. Let's have a look in here. So on the image layer page, there's a few properties. Firstly, the coordinate system. So it tells you that it's picked up AGD84, zone 54, as the coordinate system. So that's what it's acquired from the raster, from the components. You can override that coordinate system here if you wish, if this is not correct, or if you want to render it. Well, no, let me be clear about this. You can override it here if it's not correct. If you want to render it in some other coordinate system, you do that on the algorithm property page. On the layer page, you only use this coordinate system setting in emergencies. Come on to the color page. We have a grayscale option, which just simply converts everything to grayscale. Now let's take a look at a second example. Let's create a new image algorithm. This time I'm going to select land cover. Choose the... So this is not an image, but it does have a red, green, blue color band. So it can be rendered as though it's an image, even though in fact the raster itself is a classified raster. So if I zoom in, you'll see that all the pixels have a certain color. If we get some tooltips, you can see it's vegetation, forest, sparse, grassland, etc., etc., closed to open, bare areas, and so forth, water bodies. So it's a classified raster. So not quite an image, but again, we're faithfully reproducing the colors of that, the classification colors, and of course that's what you want. So let's put this onto a hill shade intensity drape. So I'll just choose a global DEM. Now zoom in. And you can see that our colors now, let me get rid of that tooltip, colors now are modulated by some hill shading. So hill shading is controlled by this shadow control. So you have a specular highlight and you have a shadow. And both of these can be turned on or off independently. So for example, let's turn off the specular highlight. And in the shadow, you can control the direction of the shadow. You can drag it around in this tool, or edit it here in these boxes. And then there's also this scale command. So you can bring down the scale of the shadow, which just lightens or deepens the level of shadow in the raster. So let's bring that down a little bit, maybe about there. You've then got some additional control for the layer. So go to Layer Property and go to the Color Control. And in here you have something called the Color Intensity Balance. So if I drag this around, if I drag it to the left, I get all shadow. If I drag it right to the right, I get all color and my shadow has completely disappeared. So if I want to fade out that shadow, I can choose something up here which just fades it out. You just get the level that you like. Perhaps type it in here if you want, and you can fine-tune your shadow that way, and the amount of color and shadow you've got. Okay, so let's create a new image algorithm. This time I'm going to choose some global imagery. So this is Blue Marble Global Imagery. And I just want to show you the time range control. So in this particular raster, there are 12 time events, 12 complete copies of the raster, in fact. So if we select progressively, let me move that out of the way, different events, you can see the amount of snow, for example, in the northern hemisphere slowly disappear as we head into northern summer, then reappear as we go back into the northern winter. So, so that gives you control over which event you can select. So you can choose a from to. In this case, each event completely erases the event before it. So we're only seeing effectively the final event. The way that you create these rasters that have multiple events in it is tricky. There are only two ways to do it. Firstly, you can create an MRR with multiple events, but to do that you'll need some programming experience and you'll need the raster SDK from MapInfo. So that's pretty much out of bounds. The second way to do it, which is an easier way, is to make a virtual raster. But of course you'll need to know how to write that virtual raster, and there is no description anywhere for how to do that. So, so it's pretty much out of reach at the present time, but in future I hope to add a tool into ProRaster that will allow you to create these rasters that have multiple events. So let's go on to another example. I'll just open an algorithm. This is these are topographic maps and they're draped on some DTM. So if I zoom in, you see that we have topographic information, and then I'm getting some shadow come through from the intensity layer, which is just a DEM. And there's about 600 topographic maps in this algorithm. They're all coming from virtual rasters, which are being warped in real time, and in turn they're being sourced from the original topographic scanned maps. So it's actually a pretty complicated algorithm. Well, it's a simple algorithm, but there's a huge amount of data behind it, and it's doing a lot of work in order to get this imagery onto the screen in real time. So let's look at blending and how we might see other information through this raster. So for example, let me add in a lookup table color layer, and I'm going to load some magnetics. So I'll just browse to that. I haven't got a raster source for it, and I'll just change it to a histogram equalized. So that's the magnetics for Australia. And I want to see my topographic data on top of that. So there it is. But I want to be able to see the magnetics through the topographic data. Now, at the moment I can't see anything. So one option we've got is to use the data conditioning erase white filter that we made before. So most of these topographic maps are white in the background. So if I do that, I certainly get something good. I can see through most of the map, and I can see my coloured magnetic imagery underneath. I might just adjust the, let me adjust the shadow of that imagery. Bring that over there, bring it down a little bit, bring this down a little bit, and just for that layer we might bring up the colour a little bit. Okay, so that's one way to do it. Another way to do it is to use blending. So let's go back to my image. We'll take that data conditioning filter back off. So let's go up to the algorithm, and I want to do some transparency blending. So go to the color page for the algorithm and turn on, let's try LightTable, and then we'll try blend. So LightTable simulates a light table, and when you turn this on you get this opacity value, which is the opacity of every layer in your algorithm. So if I bring this down, we see more of the bottom layer. If I bring it up, we see more of the top layer. And that operates over multiple layers. And the nice thing about the LightTable setting is that where you've only got one layer shining through, you get full saturation in your color, so it doesn't get blended out. Another option is to use blending, and so in this case we need to go into each layer and in the layer property adjust the opacity. So if I bring down the opacity of the topographic map, you'll see that we're seeing the topo on top, and you can bring that up or bring it down depending on how much you want to see through. So that's another option. Let's just put that back up to opaque. The third option is to use some opacity modulation, and that's done via the opacity band. So let's turn that on and then choose a raster source. I'm going to choose the magnetics. So where I have high magnetic data, I want to see the magnetic data through the topographic map. And let's just go for a linear transform. Okay, so now we're seeing something. And maybe we should just put in some clipping on this. Alright, so I'm mapping opacity to magnetics, and it's going from transparent to opaque. So when I've got high magnetics, I've got high opacity. When I've got low magnetics, I've got low opacity. So that's actually the precise opposite of what I want. So I can reverse the opacity color table. Now I'm getting what I want to see. So in these areas where I have little magnetic information, I'm seeing the topographic map. But then as I go into areas where I have high magnetic anomalies, I see the magnetic anomalies, but I don't see the topographic map so much. And you can adjust that using these clipping options. If we go to, say, an equal area transform, then you'll get a different effect. And if we just turn off this one on the bottom, turn off that magnetics, you can see the effect. So there's our variable transparency. We're seeing through the topographic layer. So just finally, we look at these layer properties. So we have a valid cell by component rule. I'll explain that in another video. You have your coordinate system, which you usually won't touch at this level. On your color page, you have your grayscale, which we've seen. You've got your color intensity balance, which we've seen, your opacity, which is for when you're blending layers manually, and you've got your interpolation override, which applies to all of the components in the layer.